Thank you, Jeff, for the kind introduction. I'm very happy to have the opportunity and to be here and share Qualcomm vision for on-device generative AI. All right, for today's talk, I'll break down to three different subjects. First, we'll looking at the general trend in Gen AI, in particular, why the on-device is a key. The second perspective is about at Qualcomm, we have conducted a lot of R&D effort in efficiency techniques. This is to allow to bring a lot of Gen AI technique and also use cases to the device. We can run them smoothly and professionally. And lastly, from a forward-looking perspective, we're looking to the future trend in terms of from a multimodality LLM perspective. What's Qualcomm's view in terms of how are we going to bring agent and then bring embodied AI to the edge in the future? All right, the first trend we are showing here probably is fairly obvious, where the transformers, right, clearly has become the de facto model architecture, for many of the AI applications. And also they are extending to more modalities. Here we're using a few examples. Actually, our AI R&D team at Qualcomm is specifically kind of working towards to share some lights to say, a lot of, potential and opportunity. So the first one is about when we're looking at the across camera, or even think about camera, LiDAR, radar all together, where we can enable this across-view attention to enable enhanced perception for autonomous driving, robotics, and think about industrial IoT, many of such, right? And also, many of you probably know Qualcomm is a world-leading wireless company. We also are applying a lot of AI transformer architecture into wireless space in terms of understanding the radio propagation environment, right? By combination of the GPS, camera, and also radio frequency signals using transformer, so we can using to improve the wireless communication effectively. And the last topic is also a very interesting one, in a sense, we are inventing a fairly general transformer architecture specifically to dealing with the geometry data. You think about points, think about lines, think about the planes, think about transformations. So where we can using what we call the geometric algebra transformers, which can respect the symmetry in the real world while trying to improve and make the performance very, very robust.